Dear students, welcome to today's class. Today I am going to explain the problems from binomial theorem, basically remainder theorem problems. Okay, so without wasting our valuable time, so I am straight away going to my class. See here, if the remainder when x is divided by 4 is 3, when x is divided by 4, the remainder is 3. Then we have to find out the remainder when 2020 plus x whole to the power of 2022 is divided by 8 is. Okay, now the question is very clear. So it was asked in 2021 mains examination. Okay, then how to approach this problem? The first given data is what? What is the first given data? The remainder when x is divided by 4. When x is divided by 4, the remainder is 3. When x is divided by 4, the remainder is 3. Okay, now we don't know the quotient. Let us say the quotient is y. Okay, right. We know that dividend is equal to divisor into quotient plus remainder. So this is equal to x is equal to 4y plus 3. X is equal to 4y plus 3. Keep it like that. So in place of x, we can substitute 4y plus 3. Now, we have to find out the remainder when 2020 plus x whole to the power of 2022 is divided by 8. 2020 plus x whole to the power of 2022 is divided by x. This remainder we have to find out. Okay, now. But one thing is clear, the remainder should be a positive integer including 0. That means this should be either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7, that's all, not 8. So your R should be either 0, 1, 2, 3, 4, 5, 6, 7. That is one thing is very clear, Okay. That means what? This is a dividend, so we don't know the some remainder. Quotient we don't know, call it as Q. We don't know the quotient. That means if you are able to express 2020 plus x whole to the power of 2022 is 22. That means dividend is equal to divisor into quotient plus remainder. That means 8 into something you have to express. 2020 plus x whole to the power of 2022, you have to express it as 8 into some integer, plus r. R is remainder. That remainder is also from 0, 1, 2, 3, 4, 5, 6, 7. So here if you see the options, all options are correct only. There is no elimination. Generally this type of problems, there won't be any elimination of the options will be there. Then how to express 2020 plus x whole to the power of 2022 as 8 into something, some integer, 8 into some integer plus r. Whatever may be the value you got here, that is your answer. Okay, so let us continue our problem. So first to take this value, that is a dividend. This is a dividend. You take this 2020 plus x whole to the power of 2022. Okay, I am starting from here. So this is equal to 2020 plus, what is your x value? What is your x value? 4y plus 3 whole to the power of 22. So this is 2023 plus 4y whole to the power of 2022. Right. So from this, can I take, I want to write as a 8 into something or at least 16 into something. Is it to write down 8 into something or 16 into something? If it is able to write 4 into something, that is also okay. Something, whatever may be that 8 you have to get either 4 into, 8 into, 16 into, 8, 20 into. If you are able to write down, that is also okay, right? So here 2023 4. Can I take anything common outside? No, I cannot take common outside. That's why I will do like this. This is a 2024 plus 4y minus 1 whole to the power of 22. So what I did is I added and subtracted 1. So now I can take 4 common outside. So here it will be divided with, if 2024 can divide with 4. That means this can be written as 4 into something you can call it as a 4 into some lambda or mu, whatever may be that, mu, 4 into mu minus 1 whole to the power of 22. 4 into something, some integer, 4 into some integer, right? Okay, happy. From this, can I write down this as a 4 into mu? So this is a 4 into mu minus 1 whole square whole to the power of 1011. So 2022, can I write down 2 into 1011? Yes, I can write it as. Now a minus b whole square, you expand it. Okay, now you expand a minus b whole square. So this is equal to, you will get, so this is equal to 4 mu whole square, that is equal to 16 mu square minus 2ab, that is equal to 8 mu plus 1 whole to the power of 1011. Okay, now from this can I take 8 common outside? Yes, we want 8 only. 8 into some lambda plus 1 whole to the power of 11. So that is equal to 1 plus 8 lambda whole to the power of 101. What is the expansion? Binomial expansion. So this is equal to 1011C0 into 1 plus 1011C 1 into 8 lambda whole power 1. So plus 1011C2 8 lambda whole power square plus so on, last one 1011C 1011 8 lambda whole power 1011. From this, what you can observe, from the here onwards, what you can observe, here 8 lambda, 8, everywhere you can take 8 common outside. So 1011C0, 1011C0 value is 1 plus 8 into some integer. You are getting or not? So 8 into some integer plus 1. That means dividend is equal to divisor into quotient plus remainder. So what is your remainder? 1. 1 is your right answer. Okay. So very easy problem. This is the only thing, one systematically. So here I have taken 4 common outside. So for that I added and subtracted 1. After getting 4, I got 8 here. So after getting 8 into something, 8. Afterwards, I applied binomial theorem. So this is the 1 is the remainder for this problem. I hope that you understand this solution. So let us go for next problem. Dear students, welcome to second problem. The remainder left out when 8 to the power of 2n minus 62 whole to the power of 2n plus 1 is divided by 9 is. That means when 8 to the power of 2n minus 62 whole power 2n plus 1, when this number is divided by 9, you have to find out the remainder. Okay, now one thing is clear, your answer should be between the sets 0 or 1 so on 8, 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. That is clear. So if you see the answers options, all options are eligible for your answer. Okay, there is no elimination of the answers, right? So this is the dividend. That means this is the dividend 8 power 2n minus 62 whole power 2n plus 1. Dividend should be written as divisor into some quotient plus remainder. That means 9 into some integer plus remainder. So the whatever may be the number, given number, you have to express it as a 9 into something or the multiples of 9 also. That means 9 into something or 18 into something or 27 into something or 36 into something also. That is also okay. Understand? 9 into or 18 into or plus 9 table plus remainder. But the remainder or should be lies between 0 to 8. So 0, 1, 2, 3 so on up to 8. Okay, now for this let us start. First I will take 8 to the power of 2n. Let us take 8 to the power of 2n. This is connected and 8 square whole power n. 8 square is 64 whole power n. 64. It is not a multiple of 9. 64 is not a multiple of 9. So therefore, but 63 is the multiple of 9. Therefore, I can write down this as a 1 plus 63 whole power n. Right. So this can be written as very clearly 1 plus 63 into some integer. Why? Because here NC 0 plus NC 1 into 63 plus NC 2 into 63 whole square plus NC 4 into 63 whole cube. From all the things you can take 63, take common outside, right? Again you take this second term, that is equal to 62 whole to the power of 2n plus 1. 2n plus 1 is an odd number. 62 is not the multiple of 9. What is a multiple of 9 means 63. So therefore 62, can I write down 63 minus 1 whole power 2n plus 1? Yes, I can write it as. So for my convenience sake, so I can take 1 minus 63, but here 2n plus 1 is a odd number. So that is a minus 1 whole power 2n plus 1 odd number means minus will come. That is 1 minus 63 whole power 2n plus 1. Okay, now, so here also if you expand this, whatever may be the expansion you do, so you will get minus 1 plus, so that means here you will get minus of 1 plus 63 into some integer you will get. 63 into some integer you will get. Understand this, right? So this is, call it as a second one, you call it as first one. Now we want the total problem, that means 8 to the power of 2n minus 62 whole to the power of 2n plus 1. This is equal to, so if you observe here, so this is a 1 plus 63, 1 plus 63 some integer minus, already one minus is there, here already one minus is there, minus of minus plus will come, plus 1 plus 63 into some integer. So 1 plus 1 is equal to 2 plus 63 some integer plus 63 some integer means 63 some integer you can write down. Understand? So this is nothing but, so this is a 2 plus 63 means 9 sevens are, that is a 9 into some integer. 9 into some integer. So what is the remainder here? 2 is the remainder. So option 2 is the right answer. So understand this problem, total problem. So wherever we have to only concentrate on the multiples of 9. Multiples of 9 we have to concentrate. Okay, 9, 18, 27, 63 like this. So I concentrated on 63. So here also 63 minus 1, 63. So everything is okay. I hope that you understand this solution. So let us go for next problem. Dear students, welcome to third problem. If 27 whole to the power of 999 is divided by 7, then the remainder is. The question is very clear. It was asked in 2017. Okay, now, right. The thing is, when 27 whole to the power of 999 is divided by 7, what is the remainder? One thing is clear, the remainder is either 0 or 1 or 2 or 3 or 5 or 6. Observe that it should not be negative number. It should be a 0 or positive integer. That means whole numbers. We can say, very simply, we can say the whole numbers 0, 1, 2, 3, 4, 5, 6 up to 6. Okay. So if you observe the options, all are eligible for answer, but there is no option elimination process. All are eligible. Okay, we will say that which is selected. Right. So coming to here, so whatever may be that 27 power 999, that means it is a dividend. Dividend should be written as the sums 7 into some integer plus, so 7 into something or 7 into something or 7 multiples, 7 into 14 into 28 into 35 into 42 into something. So this number, that means here you can write it as 14 or 7 table. 7 2s are, 7 3s are, 7, 28, 35, so on. Something you can write down. The problem is over. Now coming to see the problem. So 27 whole power 999. So what can you say this here? 27, no? Observe here, 28 is there, 28. 28 is the multiple of 7. You may take 21 also, but it takes some time. So better you take 28. 27, can I write down it as a 28 minus 1 whole power 999? You may ask us, sir, why sir you have taken 28? 28 is the multiple of 7, only that thing. So for our convenience sake, you take 1 minus 28. 1 minus 28 if you take, but in the exponent what is there? 999, which is a odd number. So it can be written as minus 1 minus 28 whole power 999. Okay now. So this is equal to minus into 1 plus 28 into some integer. So if you apply the binomial theorem, the first term is 999 C0, next minus 999 1 into 28, like this go on. From all the things you can take 28 common outside. So if you observe here, so this is a minus 1 minus 28 into some integer. So you may ask one doubt, sir, the problem is over, so now sir, so that means 7 into some integer you are written. So here minus 1, therefore minus 1 is the remainder. No, already I told what I told. The remainder should be from 0 to 6. Okay now. So this can be written as, so what I want to do is, I want to make it as a positive. And moreover, it should be multiple of 7. For that, what I do is no. So plus 6 minus 6 I will do. Plus 6 minus 6. That means what? Minus 1 minus 6 is equal to how much? Minus 1 minus 6. That is equal to minus 7 minus 28i plus 6. Plus 6. From this whole thing, can I take 7 common outside? 7 into some integer plus 6. 7 into some integer plus 6. You may ask one doubt, sir, other than 6, what can you add here? Nothing you can add. If you add 5, no, if you add minus 5, minus 1, minus 6, you cannot take 7 common outside. If you want to take 7 common outside, you have to add and subtract 6. Okay now. So that means here minus 1, minus 6, minus 1, it is minus 7. From this whole thing, you can write it as a 7 into some integer. 7 into some integer. Why? Because you can take 7 common outside here. Here also you can take 28. 7 4s are 28. 7 into something plus 6. So 6 is the answer for this problem. Okay na? So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to fourth problem. Find the remainder when 7 to the power of 96 is divided by 5. That means when 7 to the power of 96 is divided by 5, we have to find out the remainder. One thing is clear, remainder is either 0 or 1 or 2 or 3 or 4. Okay now, that means 7 to the power of 96, you have to express it as a product of dividend is equal to divisor into quotient plus remainder. Your remainder is either from 0 or 1 or 2 or 3 or 4. So here it is, this should be either 5 or 10 or 15 or 20 or 25, so on, something, multiples of 5, no problem. Multiples of 5, not only 5, multiples of 5 is also no problem. Okay now, right. Then how to proceed? So this is equal to 7 power 96. Concentrate on that multiples of 5 or 10 or 15. You have to concentrate on that. So this can be written as 7 power 2 into 48, that is 7 square whole power 48. This is a 49 whole power 48. Okay now, 49. That means how can you write down 49? So here, so on 50 will come, no? So on 50 will come, no? So 49, so can I write it as a 50 minus 1 whole power 48? I can write it as. So concentrate more on that. It is a 50. Why? You have to write down 50 multiples. Okay now. So since 48 is an even number, so this we can write as 1 minus 50 whole power 48. Okay now. So if you expand the binomial expansion, 48C0 into 1 minus 48C1 into 50 plus 48C2 into 50 square, so on. If you observe, From here also 50, 50, 50, 50, 50. You can take 50 common outside. So this value is 1 plus 50 into some integer. You can take some 50 integer. This can be written as 1 into 5 into some integer. So 50 means what? 5 into 10, 10 into q it will come. So 1 into 5 into some integer will come. So therefore, what is your answer? 1 is the remainder. I told already 50 into something is also okay. Otherwise 25 into something or 10 into something. So whatever maybe the value remains here, that is your final answer. Okay na? So this is a problem I have taken from Sengesh and very easy solution. So let us go for next problem. Dear students, welcome to fifth problem. What is the remainder when 5 to the power of 101 is divided by 13? Very clear. When 5 to the power of 101 is divided by 13, what is the remainder? So your remainder runs from 0 to 12. 0 to 12, 0, 1, 2, 3, 4, so on, 12. Okay now, right. That means you have to express 5 to the power of 1 as a some 13 into quotient plus remainder, 13 into some integer. So as I already told you, it is either 13 or 26 or 39, so on, multiples of 13, no problem. 13 into something, 26 into something or 39 into something, no problem. If you are able to express 5 to the power of 101 as a 13 or 13 multiples into some integer plus remainder, that remainder also should be lies between 0 to 12, 0 to 12. Okay now, right. Then we will start the problem. So here 5 to the power of 101. So 101, it looks like some odd number. So I can write it as a 5 into 5 to the power of 100. Okay now, right, 100, right. So this can be written as 5 into, I want some 13 or 26 or 39, so on. 13 or 26 or 39. So how can I write it as a, I can write it as a 5 square whole power 50, 2 50s are 100. So this is equal to 5 into 5 square means 25 whole power 50. 25 I got. 25 means observe here, 26 is there no. Can I write it as a, that is a 5 into 26 minus 1 whole power 50. 26 minus 1 whole power 50. So I got 26. Understand why I wrote like this, right? So this is equal to 5 into 1 minus 26 whole power 50, no problem. Why? Because 50 is a even number, right? So if you observe, so 5 into, if you expand this, expand, first term is always 1. First term is always 1 plus remaining all terms are multiples of 26. That is multiples of 26. That's all. So multiply inside. So what happens? So this is a 5 into 26 into q plus 5. So this whole thing, can I write it as a 13 into some integer plus 5. 26, no, 13 2s are, that means 13 into 10. You can write down 13 into 10. That means 13 into something. Have I expressed it or not? 13 into some integer plus remainder. What is your remainder? 5. 5 is your answer. That's all. 5 is your answer. Okay. So very easy problem. This is the only thing is you how to get in this calculation, in this whatever be the calculation, how to get either 13 or 26 or 39 like that. Okay na? So I hope that you understand this problem. So let us go for next problem. So dear students, welcome to sixth problem. Find the remainder when this is a somewhat a variety problem. So I have taken from the Sengesh textbook. Find the remainder when x is equal to 5 to the power of 5 to the power of 5 to the power of. So up to how many 5s are there? 24 5s are there is divided by 24. Okay. So if you observe same the dividend, this is a dividend, this is a divisor. So dividend is equal to divisor into quotient plus remainder. The remainder should be either from 0 to 23. 0 to 23. Okay na? So let us check the problem. So for example, see here x to the power of 5 to the power of 5 to the power of so on 5. So 24 times 5 is there. That means up to here how many 5s are there? 23 5s are there. 23 5s are there. So including this 5, these are 23 5s are there. So if you for example 5 to the power of 5 to the power of 5 to the power of 5, if you do this 23 times, definitely it will be an odd number. Sure, it will be an odd number. That means x to the power of x is equal to 5 to the power of. This whole thing you will get an odd number. Why? You are raising the power for odd number of times. Odd number of times you are raising. That's why. So this is odd number, means you can write down 2n plus 1. Okay now. So this can be written as, so x is equal to 5 into 5 to the power of 2n. Again this can be written as 5 into, so this is a 5 square whole power n. This is a 5 into, this is a 25 whole power n. I already told that 24 multiples of 24. So here 25 is there. So can I write it as a 5 into 25? Can I write it as a 1 plus 24? 1 plus 24 whole power n. Okay now. So according to the binomial theorem, so this is equal to 5 into 1 plus, so NC0 plus NC1 into 24 plus NC2 into 24 square. So this is a 24 some integer. 24 into some integer. That means this is equal to 24 into 5 into some integer plus 5. This whole thing can be written as 24 into some integer plus 5. So 5 is your answer. Okay. The only thing here what you have to observe is, so here up to this 23 5s are there. That is an odd number. If you observe that this odd number can be written as 2n plus 1. From this, the problem is follows. Okay. So very easy problem. So let us go for next problem. So dear students, welcome to 7th problem. Find the remainder when 2021 whole to the power of 2023 is divided by 7. It is a latest problem. So just June 2022 it was asked. So let us start the problem. So whatever may be that 2021 whole to the power of 2023 can be written as a multiple of 7 or 7 or multiples of 7 plus remainder. Okay now. So let us start the problem. So your problem is 2021 whole to the power of 2023. 2021 whole to the power of 2023. So this can be written as base. Let us try to write down 7 into. Why? Because it should be divided by 7. That's why this can be written as 7 into, how much you can divide? 7 into 288 plus 5 whole to the power of 2023. So you calculate that, you will get that. Okay. So this is equal to 5 plus 7 into 288. For my convenience, I am writing like this. Okay. So this is a binomial. So write the binomial expansion. So this is equal to 2023C0 5 to the power of whole power will come 2023 plus 2023C1 into 5 to the power of 2022 into 7 into 288. So on it will come. If you observe from here onwards, 7 into 288, 7 into 7 into 7 into 12. That means this whole thing you can write down 7 into some integer. You can take 7 common outside. Okay. So 2023 C0 value is 1. So altogether 5 to the power of 2023 plus 7 into something it will come. So if you divide this 7 into something with 7, the remainder is 0. Up to here the remainder is 0. Remainder is 0. No problem. So you can forget about this. You can forget about this. Now concentrate on 5 to the power of 2023. 5 to the power of 2023. 5 can I write it as a, so this is a 7 minus 2 whole power 2023. So why you have to write down 7? Always keep it in mind 7. Okay now? Always keep it in mind 7. 7 minus 2 whole 2. Welcome to the remaining solution. So this can be written as 7 minus 2. No, I can write down 2 minus 7. But here 2023 is an odd number. So that one minus 1 will come on outside. Whole to the power of 2023. So this is equal to minus 1 into, again binomial expansion, that is a 2023 C0 2 to the power of 2023 plus 7 into something you will get. Definitely 7 multiple you will get. So here the remainder is 0. So forget about this. So on the whole minus 2023 C0 value is 1. This is a 2 power 2023. So I reduced the problem. So this is our 2021 whole to the power of 2023. I made it into minus 2 whole to the power of 2023. So this can be written as minus 2 into 2 to the power of 2. You can write it as, yes, I can write it as a minus 2 have taken common. So 2 to the power of 2022 plus 1 2023. Okay now. So this can be written as minus 2 into 2 cube whole power 674. See here, 3 4s are 12, 3 7s are 28 plus 1 22, 3 6 are 18, 18 plus 2 20. So I can write it as 2 cube means 8. 2 cube means 8. That is minus 2 into 8 power 674. That is minus 2 into 8 can be written as 1 plus 7 whole to the power of 674. 674. Again I got 7 here. So this is equal to minus 2 is equal to 1 plus 7 into something. If you expand it, minus 1 7 into something. So this is equal to minus 2 plus minus 2 into 7 into something. So on the whole this is a integer of, that is equal to 7 into something, minus 2 is there. But if you observe, minus 2 cannot be your remainder. So your remainder should be positive integer including 0. Okay, 0. That means to get here remainder, what I will add, 7 mu minus 2. To get 7, what should I add? So add plus 5 minus 5. Add plus 5 and subtract 5. That means what? Minus 2 minus 5 minus 7. That means minus 2 minus 5 minus 7. You can write it as a 7 into something plus 5. So minus 2 minus 5. Minus 2 is there. You have to take 7 common outside. If you want to take 7 common outside, of course you can add so many numbers, but which is the least one you have to add. So that means add 5 and subtract 5. That means minus 2 minus 5 minus 7. Here also 7 is there. You can take 7 common outside. 7 into something, some integer, plus 5. Therefore, 5 is our right answer. Such a nice problem it is there. The only thing is reducing the problem. So always keep in mind 7. The number is 7. Always keep in mind 7, 7, 7. Throughout the problem, I am 2 cube 8. Okay, like that. Okay, 2 cube 8. 8 I am writing 1 plus 7. Okay. So dear students, I hope that you understand all these problems today what I explained. So tomorrow class with some more problems I will come before you. Until then, all the best.